Elon Musk announced on Twitter, the price of lithium has gone to insane levels. Tesla might actually have to get into the mining and refining directly at scale unless costs improve. Yes, the explosive growth of global battery demand increases to an estimated 603 gigawatt hours. To serve the huge demand in Sparks, Nevada, Tesla has huge plans.
In 2014, we projected 35 gigawatt hours of battery cells, and we're there. So we've done $6.2 billion of investment. In addition, I think we'll end up investing over $4 billion. We're adding another 4 million square feet of manufacturing space.
The final product is a new battery with a life cycle of up to 30,000 cycles, equivalent to 82 years, and it'll optimize the charging time to 10 minutes. What type of battery is being mentioned? How does it play an inevitable role in the transformation of the industry? Well, before we begin, let's make sure you subscribe, and if you haven't already, ring that icon bell, because you'll never miss on those future updates from Tesla Car World. Now that we've taken care of that, let's get started on today's episode. Lithium titanate battery, LTO. The chemical formula is Li2TiO3, and the anode material, lithium titanate. It's a rechargeable battery that has the advantage of charging faster and a longer life cycle than other lithium-ion batteries. The first question, what's the pricing advantage of an LTO battery? To highlight the price advantages, making comparisons between the same voltage of 40 AH 3.2 volt, the price of the LTO battery is $38.70 US, which is nearly $10 US cheaper when compared to the price of $48.58 US for a lithium iron phosphate battery. That's your LiFePO4. In addition, you'll save another $13.95 US by purchasing an electric car using the LTO battery instead of one using a lithium-ion battery at $52.65 US. To be honest, the price of electric vehicles will be influenced by reducing battery price. Therefore, when a product's powered by any type of battery, the price of that battery determines the price of the product. So what stands out about the life cycle of an LTO battery? The life cycle of these batteries is impressive, exceeding 30,000 cycles during cell life, which is 60 times more than competitive lithium-ion technology like lead-acid, which is 500 to 1,000 cycles. Furthermore, LTO batteries are making 10 times distance from lithium iron phosphate, and that's like 3,000 to 5,000 cycles. On the other side, the cycle life of LTO batteries gives it a lifespan up to 82 years. That's higher than 27 times of lead-acid batteries, which have a life of 3 to 5 years. And it's over 4 times higher than that of a phosphate battery with a lifespan of 20 years. The test below will partially demonstrate why they're so efficient. When the battery's discharged at 2C, the LTO battery can still function normally as a daily duty cycle. That means that voltage has no effect on the battery during operation. As a result, it can be grouped alongside other long-life infrastructure such as transformers, transmission lines, and generators, and doesn't need to be replaced for an extensive period of time. The second reason is that, unlike other types of lithium-ion batteries, the LTO battery has a life cycle of up to 82 years because charging and discharging rates have little effect on them. They're suitable for all charge and discharge rates ranging from 1C to 3C. Overall, LTO batteries have the longest cycle life of all batteries, and the testing results are proven that no battery failure occurs up until about 82 years of lifespan. So how does Tesla plan to use this long-lasting battery? As Elon Musk stated, the price of lithium's risen to an absurd level in order to fulfill future demand for batteries. Tesla intends to conduct research, explore, and manufacture batteries to fulfill Tesla's own needs as well as those of the EV industry in general. Using titanium material in combination is one of the most realistic strategies of lowering battery cost. Combining lithium and titanium material to create a new type of battery not only reduces cost but improves battery quality. Specifically, the price of titanium in December 2022 is $4,101 per ton. That's less than 9 times of lithium at $37,000 per US ton. As a result, when compared to present pricing, this combining material will save a significant amount of money in production cost. Furthermore, lithium batteries combine with titanium, which greatly improves durability and life cycle, because titanium is unaffected by environmental factors like resistance, pressure, and operating in a wide thermal range. To achieve the goal gradually, Tesla has invested over $10 million in building their own factory. That plant is built in Nevada.
Over 5 million square feet, 11,000 team members, and we have 3,200 acres of adding another 4 million square feet of manufacturing space, and at least 3,000 jobs, direct jobs, and I think it'll probably end up being more than that.
The plant is outfitted with cutting-edge technology for refining and producing batteries. It's certain that this is Elon Musk's big footprint marking Tesla's battery technology in the EV industry. Next, what advantages do these LTO batteries provide in terms of charging and discharging? When compared to traditional lithium-ion batteries, they take about 2 to 3 hours. But the LTO battery can be charged 18 times faster in 10 minutes. LTO batteries are the sole option for high-speed charging because LFP technology does not permit continuous high-speed charging and discharging. The maximum charging and discharging current for this battery is typically 10 C, which is 400 amperes. The standard lithium battery has no charge and discharge capacity below 0 C and cannot function correctly, whereas the lithium titanate battery has a charge and discharge conversion efficiency of 86% in a temperature range of minus 35 degrees Celsius to 70 degrees Celsius. The performance is significantly better than 95% or higher. On the other hand, the lithium titanate battery utilized titanate nanocrystals instead of carbon on the anode surface. This provides the anode with a surface area of around 100 square meters per gram compared to 3 square meters per gram for carbon. That allows electrons to enter and exit the anode quickly. Furthermore, the redox potential of Li plus intercalation into titanium oxide is higher than that of Li plus intercalation into graphite. Because the charging current is higher, this results in faster charging. Lithium titanate cells last for 3,000 to 7,000 charge cycles. There can be a life cycle of approximately 1,000 cycles before reaching 80% capacity when charged and discharged at 55 degrees Celsius, equivalent to 131 degrees Fahrenheit, instead of 25 degrees Celsius, which is 77 degrees Fahrenheit on the standard temp. Furthermore, during the cycle, the volume change of lithium titanate batteries is only 0.1% to 0.3%. This can help to avoid structural changes due to material elongation changes while charging and discharging. As a result, the electrode's performance improves and the substantial attenuation of the specific capacities reduced. The cycle process does not produce an SEI film. Other lithium batteries experience a 10% volume expansion during cycle, resulting in battery swelling and the formation of passive SEI film on the electrode surface. Both of these will significantly reduce the battery life. Furthermore, when compared to carbon anode material, lithium titanium has a higher lithium-ion diffusion coefficient. The lithium titanate battery created using cutting-edge technology can be fully charged in 10 minutes. This is a tremendous step that no conventional battery can make, because excessive charging time has always been an impassable barrier in the development of electric automobiles. For example, a typical electric bus has a charging time of as little as 4 hours. Instead, that can be shortened 24 times with a charging time of 10 minutes for a full battery pack. Fast charging for electric vehicles is always the future trend, and buyers do not want to wait for charging for an extended period of time. Next, what is the LTO battery's capacity to reach that rapid charge rate? The LTO battery 40AH weighs 250 grams less than 630 gram with a 40AH LFP cell at 880 grams. However, the energy density is relatively the same because the LTO battery has a nominal voltage of 2.3 volts, which is less than the 0.9 volts with an LFP cell at 3.2 volts. The battery's construction is a critical aspect in its success. It employs the utilization of 2 battery terminals. The The first component is an anode. Instead of employing carbon on the anode surface, LTO batteries use lithium titanate nanocrystals to improve surface area. This permits electrons to flow faster in and out of the anode than in normal lithium-ion batteries. The cathode comes next because lithium titanate is employed in a double-layer cathode. These fuel cells have two material layers, Layer 1 and Layer 2, which enable the manufacture of high-power molten titanate fuel cells to perform more efficiently. Considering appearance, the LTO battery appears to be the same cylindrical shape as the 4680 or 2170 battery. However, it's much larger in size and much longer. Each cell is 66 millimeters in diameter and 160 millimeters long. Furthermore, each of the two sides will have additional connectors for customizing the battery pack, making the total length 202 millimeters, including the two connectors. Furthermore, the LTO battery is encased in a blue plastic shell. This is the color of most solid-state lithium batteries on the market today. In reality, producers and users can create an LTO battery system with the appropriate quantity of batteries based on usage requirements. The most common is that the lithium titanate cell is precisely packed into 6 pieces, allowing a pack with a voltage of 10.8 to 15.9 volts to be built. In a heavy-duty industry like electric car production, hundreds or thousands of units can be combined to form a unitary pack. Importantly, to link the cells, one can use original jumpers or ones designed for Winston cells, which work as well to suit with packing demand. Once connected to the pack, we have more options for cell arrangement, such as flat, pyramid, or any other shape that best suits your needs. Until now, the LTO batteries have been known to be the safest of all battery types. So how safe is it? Because LTO batteries are not flammable, there's no risk of fire, explosion, or toxic substance leakage. Moreover, unlike other types of batteries, LTO batteries do not spontaneously ignite when internal temps reach dangerously high levels. They also do not emit smoke, which is a common issue encountered with LFP batteries. For example, when an LFP battery overheats or burns, it generates enormous amounts of carbon monoxide, carbon dioxide, and hazardous substances in high concentrations. Furthermore, even in small quantities, life-threatening gases like hydrogen fluoride can be produced. Because lithium titanate batteries are completely free of carbon, they prevent thermal runaway or overheating, which is a major cause of fires in traditional energy storage systems. Lithium titanate technology enables for safe, user-friendly, low-risk energy storage in any application without the risk of fire or explosion. Furthermore, in terms of LTO battery safety, the higher level of safety of LFP batteries is due to this technology's lower operating voltage. Because titanate batteries are carbon-free, they avoid thermal runaway or overheating, which is the leading cause of fires in traditional energy. Because of the nanotechnology used, the storage low temperature performance of LTO batteries can achieve up to 80% of the full charge capacity at minus 30 degrees centigrade. So, what is the LTO's battery operating temp range? It can be used in temperatures ranging as low as negative 50 centigrade up to 65 degrees centigrade with little loss of capacity or performance. While some batteries lose performance in cold conditions, LTO cells continue to operate normally in temps as low as negative 50 centigrade. Special products can work stably at negative 50 centigrade without affected by the environment and temperature. At low temperatures, the lithium titanate anodes will not appear to cause short circuits or worsen the anode dendrites when charged at negative 30 centigrade, which is not possible with graphite anodes. It can be swiftly charged and discharged in a variety of settings, making it ideal for automotive application. The next part, how are LTO batteries produced? A process for producing lithium titanium, which is suitable for electrodes for lithium-ion batteries used. The process is described under the following steps. Step 1, a production process for efficiently producing lithium titanate using a dry method. Step 2, a process for producing lithium titanate in which vaporization loss of lithium compounds in the sintering reaction can be suppressed, so that the ratio can be freely controlled in the range of 0.78 to 0.82. Step 3, a process for finally producing lithium titanate in which persistence of titanium dioxide as a raw material can be suppressed. This invention can efficiently produce lithium titanium with the necessary composition under the specified production conditions, resulting in a negative electrode and a lithium-ion battery with a high discharge capacity and better charging and discharging capability. In the final part, what's the future outlook for LTO batteries? In the overall EV sector, the American government is in favor of enacting new transportation laws and policies based on environmental consideration. The U.S. Department of Energy has announced plans to invest $258 million into advanced vehicle technology, including LTO batteries, lead-acid batteries, lithium-ion batteries, as well as other types of batteries. This will have a positive impact on the overall demand for electric vehicles as well as their components, and will cause it to strongly grow in the U.S. over the forecast period 2022 to 2030. Therefore, recent advances in energy storage capacity have seen LTO batteries win over EV manufacturers. In a specific example situation, the excellent rapid charging characteristics of lithium titanate batteries and 90% charging efficiency, combined with wireless charging plus high-rate performance and long battery life, they all make development of wireless rechargeable energy technology. Charging online or charging when running will become a possibility. They'll be successfully applied to electric vehicles like electric buses, electric motorcycles, trams, AGVs, and some emergency equipment. Moreover, the fast charge and long service life of lithium titanium greatly will reduce the number of batteries needed for electric vehicles, thereby reducing the cost of the entire vehicle. In recent years, titanate batteries are used in certain Japanese-only versions of Mitsubishi's MiEV electric vehicle, as well as Honda's EV Neo electric bike and the Fit EV. They're also used in the Tosa concept electric bus because of the battery's high level of safety and rechargeable capability. LTO batteries are used in car audio applications as well as mobile medical devices. Overall, the use of lithium titanate nanoparticles drastically improves cycle life and slashes charge time. It allows the battery to withstand high temp and without a drop in performance. The transition to EVs will play an important role in combating air pollution around the world. Besides application in the EV industry, the LTO batteries are being used in others like mobile, communication application providers, national grid, rail transit, military systems, power battery, energy battery, lithium titanium communication base station power backup supplies. And in the past 2 years, lithium titanate batteries have been successfully applied in two-wheelers and tricycles. Furthermore, an LTO battery is also used in the S Pen that comes with the Samsung Galaxy Note 20 Ultra 5G. So who makes LTO batteries? Yinlong Energy International Pte. Limited is the international office of Gree Altair Nano New Energy. They provide energy storage systems, LTO batteries, commercial electric vehicles, and electric chargers. Yinlong Energy International is a leading lithium titanate battery producer in China, and they have been producing qualified lithium titanate batteries since 2015 and became the #1 lithium titanate battery producer of the world. Their batteries are widely used in electric buses in China, and the electric bus has been running over 7 years with no problem. They provide an 8-year warranty, and the LTO battery should work for over 82 years. So what do you think of this new battery, and how will Tesla use it for their electric cars? Let us know what you think by leaving a comment under the video. That's all for today's episode, and thanks for watching and your support of the channel. If you enjoyed the video, please click the like button, share the video with your friends, subscribe if you haven't already, and ring that bell. That way you'll be up to date on all exciting developments in the world of EVs. Once again, thanks so much. We hope to see you again next time, but until then, take care and be safe.